Welcome to Frost and Sullivan's Growth Podcast. In each episode, we take a deeper look at transformative shifts shaping global ecosystems, from industry megatrends and technology innovation to evolving customer expectations. Today, we're exploring battery recycling innovation, unpacking how advanced recovery technologies, artificial intelligence, automation, and circular economy models are transforming battery recycling from a waste management activity into a strategic source of critical materials and long-term value creation.
Why battery recycling is becoming a strategic industry. Battery recycling is moving to the center of energy transition strategies as demand for electric vehicles, energy storage systems, and critical battery materials continues to accelerate. Organizations are increasingly viewing end-of-life batteries as valuable resource reservoirs capable of supplying lithium, nickel, cobalt, graphite, and other critical materials needed for future manufacturing. At the same time, sustainability requirements, supply chain security concerns, and circular economy initiatives are increasing the strategic importance of material recovery ecosystems. What was once considered a downstream waste activity is evolving into a critical industrial capability supporting future electrification. How is your organization incorporating battery recycling into long-term resource security and growth strategies?
Strategic imperatives. Reshaping battery recycling. Several strategic imperatives are accelerating innovation across the battery recycling ecosystem. Geopolitical pressures surrounding critical mineral supply chains are encouraging nations and manufacturers to diversify sourcing strategies and strengthen domestic recovery capabilities. Disruptive technologies such as solid-state batteries, silicon anode batteries, and sodium-ion batteries are creating new recycling requirements and opportunities. Meanwhile, transformative megatrends including electrification, EV adoption, energy storage expansion, and battery manufacturing investments are increasing future volumes of recyclable battery materials. Together, these forces are reshaping how organizations think about battery lifecycle management and material circularity. Which strategic imperative will have the greatest impact on your battery value chain over the next decade?
Technology innovation, driving recovery efficiency. Innovation is increasingly focused on improving recovery rates, lowering environmental impact, and increasing the value of recovered materials. Advanced recycling technologies, including hydrometallurgy, pyrometallurgy, and direct recycling, are improving material recovery efficiency while reducing energy consumption. Artificial intelligence, computer vision, and robotics are enabling more accurate battery identification, sorting, and disassembly processes. At the same time, emerging purification and recovery technologies are improving the quality of recovered lithium, cobalt, nickel, manganese, and graphite, supporting more resilient and circular battery supply chains. How are advanced recycling technologies influencing your organization's circular economy priorities?
Companies and investments. Accelerating industry growth. Industry investments across North America, Europe, and Asia signal growing confidence in battery recycling as a strategic industrial capability. Organizations including Ascend Elements, Lohum, Li-Cycle, Glencore, and Fordham Battery Recycling are expanding recycling infrastructure and recovery capacity. Meanwhile, innovators such as Umicore and Lohum are advancing recovery technologies, battery traceability solutions, and circular business models designed to maximize long-term material value. What capabilities will distinguish leaders in the future battery recycling ecosystem?
Growth opportunities. Creating circular value. Several high-impact growth opportunities are emerging across battery recycling. Second life battery systems are creating value through stationary energy storage, backup power solutions, battery refurbishment, and diagnostics platforms. Integrated circular economy hubs are combining collection, repair, reuse, remanufacturing, and recycling into unified ecosystems designed to maximize resource utilization. Digital battery passports, closed-loop recovery systems, and cross-industry data sharing models are further strengthening traceability and material circularity across battery supply chains. Organizations that align technology innovation, recycling infrastructure, and circular business models will be best positioned to capture long-term value from the growing battery economy. Which circular value creation opportunity aligns most closely with your organization's growth strategy?
Thanks for joining us on Frost and Sullivan's Growth Podcast. For access to our research, competitive benchmarking, and best practice frameworks, head over to frost.com or email hello@frost.com. We'll be back soon with more to help you stay clear-headed and growth ready.